All right, let's jump right in. So tonight is chapter 4. Lots of videos, lots of stuff, and quite a few questions. Any questions or comments before we get started into the review? All right, let's get going.
Oh, wow.
All right, go buy more books. I should just pull those out. But so chapter 4 has basic electrical concepts, review, decibels, RMS, peak envelope power, resistors, capacitors, inductors. This is the big kahuna. Series and parallel circuits, transformers and vacuum tubes, reactance, impedance, and resonance, semiconductors and ICs, and basic test equipment. 7, count them, 7. And 105 questions and 43 pages. Boy, they stuff a lot of stuff in 43 pages. Look out.
Makes my head hurt.
Yeah. And what was it? 5 videos that were longer than 30 minutes each.
So this chapter makes up a third of the question pool.
Pretty much. So our first section is all about power, decibels, and 5 questions. So as a reference for decibels, there are several commonly used reference powers and voltages such as, oh, I'm going to need to move this over so I can read the rest of the screen. There are several commonly used reference powers and voltages such as 1 volt or 1 millivolt. When a dB uses such a reference, dB is followed with a letter. Here are the most common. dBV means a dB with respect to 1 volt, or the voltage reference is equal to 1 volt. dB with the micro V means dB with respect to 1 microvolt, and dBm with the dB with respect to 1 millivolt. And then I've added in the formulas for converting dB to percentage and vice versa. So for power, the percentage of power, you would use the dB10 log and the percent of power divided by 100. And if you're trying to solve for percentage of power, you take 100% times the log of dB divided by 10. Move this over here. And for voltage, it's dB 20 log with the percentage of voltage over 100. And then, gosh, I gotta keep moving this. For percentage of voltage, we have 100% times the log of the dB divided by 20. So what dB change represents a factor of 2 increase or decrease in power?
3 dB. 3 B.
Baker is correct, approximately 3 dB. How many watts of electrical power are used if 400 volts DC is supplied to an 800 ohm load? A, 0.5 watts, B, 200 watts, C, 400 watts, or D, 3,200 watts?
Bravo.
It's Bravo.
Bravo is correct. It's 200 watts, and then I went ahead and put the math. I'm trying to add the math in all of these questions tonight. So you would take power equals E squared over R. How many watts of electrical power are used by a 12-volt DC light bulb that draws 0.2 amperes? A, 2.4 watts, B, 24 watts, C, 6 watts, or D, 60 watts?
Alpha.
Alpha.
Alpha is correct, and the formula is P equals E times I, so that ends up being 2.4 watts. How many watts are dissipated when a current of 7.0 milliamperes flows through a 1,250 ohm resistance? A, approximately 61 milliwatts, B, approximately 61 watts, C, approximately 11 milliwatts, or D, approximately 11 watts?
Alpha. I think it's alpha.
Alpha.
Alpha is correct, and the formula is P equals I squared times R equals 61.25. What percentage of power loss would result from a transmission line loss of 1 dB? A, 10.9%, B, 12.2%, C, 20.6%, or D, 25.9%?
Charlie.
Charlie
C.
is correct. And the percentage of power is the 100% times the log of -1/10 is, oh, did I? Oh, yeah. The actual, move this over, come on. So the actual loss is, you take the -1 and it ends up being the 20.6%.
What?
So we're solving, let me move this up out here out of the way. So what I added was the math on that page 4.3, and they're solving for the percentage of power and then subtracting that from 1. So you end up with 79. So 100 minus 79 gives you the answer of the line loss. So 79.4 is actually reaching the antenna, but 20.6 is being lost in the feed line. That good now? Or did I
Now I
confuse
got it.
Okay. Okay. Now I wish I could just keep this out of the way. Okay, section 4.2 is for AC power. There's 8 questions, and we'll just get right into them. What is the output peak envelope power from a transmitter if an oscilloscope measures 200 volts peak to peak across a 50 ohm dummy load connected to the transmitter output? A, 1.4 watts, B, 100 watts, C, 353.5 watts, or D, 400 watts?
You got to remember these P over I formulas work with average power, not average, but RMS power, not peak or peak to peak. So you got to cut the peak to peak in half and then multiply by 0.7. So you get 70.7 volts instead of 200 volts. Then you can put that in the formula.
Yeah, so here's the math Daniel's talking about. Here's the 0.707 times 200 divided by 2, and then that's squared over 50, so you get 4,999 divided by 50 equals the 100 watts, which is B Baker.
The 0.7 is half the square root of 2. That gets us to the RMS. But you also, because you're peak to peak, you got to cut it in half, which is the 2 in the denominator.
Right. Yeah, that's helpful. Thanks.
What value of an AC signal produces the same power dissipation in a resistor as a DC voltage of the same value? A, the peak-to-peak value. B, the peak value. C, the RMS value. Or D, the reciprocal of the RMS value.
Charlie.
Charlie,
Yeah, it's an RMS value. It's root mean
RMS.
squared. It's a very big mathematical calculation, but just remember RMS. The 110 volts we have in our wall outlets, that's RMS.
okay.
And just double checking, there's a question in the chat. Are we
Okay.
allowed to use equations? Are we allowed to have equations with us during the test? You can't bring in anything to the test, but you can, as soon as they tell you start the test, you have blank pieces of paper and you do the mental brain dump of all of the equations, goes out through the fingers and through the pencil, and you write them down. So Jason is correct. You write them down on your blank paper, but you can't bring it in with you. Okay. What is the peak-to-peak voltage of a sine wave with an RMS voltage of 120 volts?
Bring
A,
in your friend of 0.7 in there. Go ahead.
okay, A,
You-
84.8 volts. B, 169.7 volts. C, 240 volts. Or D, 339.4 volts.
Sounds like Delta.
Delta,
Delta is correct. So you take your peak to
okay.
peak times 2 times 1.414 times the 120, and you end up with a 339.4. What is the RMS voltage of a sine wave with a value of 17 volts peak? A, 8.5 volts. B, 12 volts. C, 24 volts. Or D, 34 volts.
Bravo.
Bravo,
Bravo is correct. You take the VRMS,
got it. Yeah.
0.707 times the 17 gives you your 12. What is the ratio of peak envelope power to average power for an unmodulated carrier? A, 0.707, B, 1.00, C, 1.414, or D, 2.0.
We've always considered this kind of a trick question because it is an
Charlie.
unmodulated carrier, then all the energy is
Yeah.
going in the peak envelope power. So it's 100%,
Nice.
which is
Okay.
B. Which is B.
What would be the RMS voltage across a 50 ohm dummy load dissipating 1,200 watts? A, 173 volts. B, 245 volts. C, 346 volts. Or D, 692 volts. The answer is B,
B, Bravo.
245. So you take your peak envelope power times your resistance and take the square root of that. So there's the math down at the bottom. I was lucky in the general stuff because they did give almost all of the math for all of the questions, so I cut and pasted it. So hopefully that helps out. What is the output peak envelope power of an unmodulated carrier if an average reading watt meter connected to the transmitter output indicates 1060 watts? A, 530 watts, B, 1060 watts, C, 1500 watts, or D, 2120 watts.
Remember I said it was 100%? This is the same question that we had 2 questions ago.
Oh, okay, so it's B Bravo, 1060 watts, right? Okay,
Anytime it's unmodulated, anytime unmodulated, look for the 100%.
100%, okay.
What is the output peak envelope power from a transmitter if an oscilloscope measures 500 volts peak to peak across a 50 ohm resistive load connected to the transmitter output? A, 8.75 watts, B, 625 watts, C, 2,500 watts, or D, 5,000 watts? There's the answer down there. It's 100 watts.
Wait,
Oh, wait a sec. I
No.
copied the wrong.
Copied the wrong.
Sorry, I copied
Yeah,
the wrong
okay.
one.
I
Stope.
think it's 620,
Yeah.
Bravo.
625, yeah.
625.
If you take-
and
If you take 500 divided in half, you got 250 times 0.7, you get 187. You square that and then divide by 50, I think it is.
550,
you get-
okay. Okay,
Okay, hang on a real quick sec. I want to catch that right now before I
Go too far, yeah.
recycle these. Okay.
Yeah, the first thing on these peak-to-peak questions, I get the voltage back down to RMS. So I cut it in half, the motor by 0.7, and get the RMS voltage. Then I can put it back in my formulas.
Oh. No, I really messed it up. I lost where I was at. Okay, 1060.
B 514 and B. You're looking at 47. Middle 47.
Let me just, where'd my pen go? I'm just gonna write it down.
G5B14.
Let me just write that down because I,
G5B14.
oh,
bingo.
come on, pen. Okay, there, the dead pen too.
Okay, we'll be
Right.
great.
I'm
Kansas
just
Wars.
having tons of fun. Okay. Now to bring this back up. Okay. Now, how do I start back up on this?
Go to slideshow and then.
There it is. There it is.
F5, yeah.
From
For the-
current
from the
5.
Current slide, yeah.
Okay, so that's the one I need to fix. Sorry about that. Okay. Meanwhile, back at question land. So section 4.3, basic components, has 5 questions. And components, wow, this is going to really need to be moved because there's a lot of eye chart here. The 3 most basic types of electronic components are resistors, capacitors, and inductors or coils. Resistors designated with an R have a resistance specified in ohms, kiloohms, megohms. Capacitors designated with a C store electric energy and have values specified in picofarads, nanofarads, and microfarads. Inductors designated with L store magnetic energy and have values measured in nanohenries, microhenries, millihenries, and henries. The following terms apply to all components and may be important when selecting a component for a design or for repair. The nominal value is the quantity of a specific characteristic that the component is manufactured to exhibit, such as 10 ohms resistor. The tolerance is the amount by which actual value is allowed to vary from the nominal value, usually expressed in a percentage, such as a 5% tolerant resistor. The temperature coefficient is the variation of the component's actual value with temperature, such as 10 megohms per degree centigrade. Temperature coefficients or TEMCO may be either positive, increasing the value with temperature, or negative. For a positive temperature coefficient, the temperature increases, so does the resistance. Most components are available with different values at TEMCO. The power or voltage or current rating is the rated ability of the component to withstand heat, dissipate power, such as a quarter-watt resistor. Use the following conversion factors to convert units from one metric prefix to the other. Divide by 1,000 to convert pico to nano, nano to micro, micro to milli, kilo to mega, and mega to giga. Multiply by 1,000 to convert from nano to pico, micro to nano, milli to micro, mega to kilo, and giga to mega. All righty. In which symbol in figure G7-1 represents a field effect transistor?
Okay.
Charlie,
Charlie is correct. The symbol number 1, which is field effect right
Yeah.
there. Which symbol in figure G7-1 represents a Zener diode? Symbol 4, symbol 1, symbol 11, or symbol 5?
Delta,
Delta is correct. And that is right here. Which symbol in figure G7-1 represents an NPN junction transistor? Symbol 1, symbol 2, symbol 7, or 11?
Bravo,
Bravo.
Bravo, symbol 2.
Bravo is correct right there. Which symbol in figure G7-1 represents a solid core transformer? I'll just let
Charlie.
everybody answer.
Charlie.
Harley.
Symbol 6.
Charlie
6.
is
Oh,
correct right there.
that one.
Which symbol in figure G7-1 represents a tapped inductor?
Alpha.
Alpha. Number 7.
Alpha is correct, and he's right down here.
Yeah, that makes it variable. That's center tap. So that's the tuning of that circuit.
Okay. Enough schematics. So inductors and inductance, there's only 2 questions on this one. What is an advantage of using ferrite core toroidal inductor? A, large values of inductance may be obtained. B, the magnetic properties of the core may be optimized for a specific range of frequencies. C, most of the magnetic field is contained in the core. Or D, all these choices are correct.
Delta.
Delta.
Delta is correct. All these choices are correct. What determines the performance of a ferrite core at different frequencies? A, its conductivity. B, its thickness. C, the composition or mix of materials used. Or D, the ratio of the outer diameter to the inner diameter.
Charlie. The mix.
Charlie, the mix of the materials is correct. Capacitors and capacitance, 5 questions. What is the value in nanofarads of a 22,000 picofarad capacitor? A, 0.22, B, 2.2, C, 22, or D, 220?
Charlie.
Charlie.
Charlie is
22, yeah.
correct. What is the value in microfarads of a 4,700 nanofarad capacitor? A, 47, B, 0.47, C, 47,000, or D, 4.7?
Delta.
Delta is correct. Which of the following is an advantage of an electrolytic capacitor? A, it has tight tolerance. B, much less leakage than any other type. C, high capacitance for a given volume. Or D, inexpensive RF capacitor.
Charlie.
Yeah, the Jenny's silver, blue, or black, and they used a lot of times in power supplies.
Okay. Why is the polarity of applied voltages important for polarized capacitors? A, incorrect polarity can cause the capacitor to short circuit. B, reverse voltages can destroy the dielectric layer of the electrolytic capacitor. C, the capacitor could overheat and explode. Or D, all these choices are correct.
Delta.
Delta.
Delta kaboom. All these choices are correct. It could do a lot. Which of the following is an advantage of ceramic capacitors as compared to other types of capacitors? A, tight tolerance. B, high stability. C, high capacitance for a given volume. Or D, comparatively low cost.
Delta.
Delta.
Low cost.
Delta is the low cost, correct. Next section is on transformers, 4 questions. What causes a voltage to appear across the secondary winding of a transformer when an AC source is connected across its primary winding? A, capacitive coupling. B, displacement current coupling. C, mutual inductance. Or D, mutual capacitance.
Charlie. Mutual inductance.
Charlie, correct. What happens if a signal is applied to the secondary winding of a 4-to-1 voltage step-down transformer instead of the primary winding? A, the output voltage is multiplied by 4. B, the output voltage is divided by 4. C, additional resistance must be added in series with the primary to prevent overload. Or D, additional resistance must be added in parallel with the secondary to prevent overload.
Alpha.
Alpha
Alpha is correct,
multiplied by 4.
multiplied by 4.
Which-
What is the RMS voltage across a 500 turn secondary winding in a transformer if the 2250 turn primary is connected to a 120 volts AC? A, 2370 volts. B, 540 volts. C, 26.7 volts. Or D, 5.9 volts.
See,
Charlie.
Charlie.
Charlie is correct, and here's the math
120.
for that.
Okay.
So the ratio of 500 over 2,250 times the 120 gives you your 26.7. Why is the conductor of the primary winding of many voltage step-up transformers larger in diameter than the conductor of the secondary winding? A, to improve the coupling between the primary and the secondary. B, to accommodate the higher current of the primary. C, to prevent parasitic oscillations due to the resistive losses in the primary. Or D, to ensure that the volume of the primary winding is equal to the volume of the secondary winding.
Bravo.
Bravo.
Higher.
Bravo is correct. Higher current is in the primary windings. Components in series and parallel circuits. Here comes some fun stuff. How does the total current relate to the individual currents in each branch of a purely resistive parallel circuit? A, it increases the average of each branch current. B, it decreases as more parallel branches are added to the circuit. C, it equals the sum of the currents through each branch. Or D, it is the sum of the reciprocal of each individual voltage drop.
Charlie.
Charlie, it equals the sum of the current.
Yep.
That
Yeah,
is correct. Parallel, you
add
add
them
them
up.
up.
Okay.
Which of the following components increases the total resistance of a resistor? A, a parallel resistor. B, a series resistor. C, a series capacitor. Or D, a parallel capacitor.
Bravo.
Increase the total resistance is series resistor.
Although a series
B.
capacitor would affect it too, we gotta say. But still, it's Bravo.
Yep. What is the total resistance of 3 100 ohm resistors in parallel? A, 0.30 ohms. B, 0.33 ohms. C, 33.3 ohms. Or D, 300 ohms.
Charlie.
Charlie, 30.
Charlie is correct, 33.3. So you
Yeah.
take each one of them and add them, and then 1 over the
Divide.
top
Yeah.
gives you 100 over 3,
Yeah.
gives you the 33. If 3 equal value resistors in series produce 450 ohms, What is the value of each resistor? A, 1,500 ohms, B, 90 ohms, C, 150 ohms, or D, 175 ohms?
Charlie, 150 ohms, because you got 3.
Correct. So resistors in series, you just add the 3.
Add, okay.
What is the equivalent capacitance of two 5.0 nanofarad capacitors and one 750 picofarad capacitors connected in parallel? A, 576.9 nanofarads, B, 1,733 picofarads, C, 3,583 picofarads, or D, 10.750 nanofarads.
Delta.
Delta is correct. So you first need to convert those 5 nanofarads to picofarads. So that would give you 5,000 picofarads. And then you take each one of those and add them into the 750 over 1 gives you the 577 picofarads.
Wait, that's not right. That's not on there.
Yeah,
You just
Oh.
add them up. You just add the 3 to, you just add them up.
that's what I thought too, but
You get delta.
You just add them up,
I-
yeah.
You
yeah.
covered this little
I
answer.
did another wrong copy and paste. Hang
Okay.
on. So another wrong copy and paste.
Yeah.
You just
Need a
add them
better
together.
pin. Sorry. Where's my
Hey,
other?
Yeah, that's
first
what I
time
saw.
through, Jim, that's not bad. It is a lot of copying, I think.
It's a lot to
Yeah,
do.
copies and pasting here. Okay, so that is G5C08. So much for the quality control tonight, folks.
No, it's good.
It's all right.
Sorry.
Okay.
You got 3 classes you're doing this to, yeah.
Yeah, appreciate your work.
All righty. What is the capacitance of 3 100 microfarad capacitors connected in series? A, 0.30 microfarads, B, 0.33 microfarads, C, 33.3 microfarads, or D, 300 microfarads?
Charlie,
Charlie.
33.3 divide, yeah, okay. Got
Okay,
it.
and 33.3, and if they were in parallel, so this is where I started copying the
Yep.
one versus the other, you just add them up. What is the inductance of 3 10 millihenry inductors connected in parallel? A, 0.30 henries, B, 3.3 henries, C, 3.3 millihenries, or D, 30 millihenries?
Charlie,
Charlie.
Charlie is correct. And if they were in series, you would just add them up to the 3 or 30 millihenries. Ugh.
You treat inductors like resistors.
yeah, they're like resistors.
Okay. What is the inductance of a 20 millihenry inductor connected in series with a 50 millihenry inductor? A, 0.07 millihenries, B, 14.3 millihenries, C, 70 millihenries, or D, 1000 millihenries?
Charlie,
Charlie is correct. You just add them up. And if you had them in parallel, there's the math down here. In,
Parallel is going to be the number below 20. So it'll be 14.3.
Yep.
That's kind of the fast way to do it.
good point.
what is the capacitance of a 20 microfarad capacitor connected in series
Oh,
with
yeah.
a 50 microfarad capacitor.
Here's your answer now. That's the B. Yeah.
Just did it.
You just did that one, 14.3.
When you do the inverse of reciprocal situation, you're looking for the number just below the smallest value. That's a fast way to double check your answer.
Yeah, I like that, Daniel. That's
Mhm.
good.
It's a good one.
Which of the following components should be added to a capacitor to increase the capacitance? A, an inductor in series. B, a resistor in series. C, a capacitor in parallel. Or D, a capacitor in series.
Charlie.
Charlie is correct. Add another capacitor in parallel.
Yep.
Which of the following components should be added to an inductor to increase the inductance? A capacitor in series. B, a resistor in parallel. C, an inductor in parallel. Or D, an inductor in series.
Inductor in series, delta.
Delta is correct, an inductor in series. Oh,
This is a
What the-
one. We're in parallel. This is 15. Yeah. We're in parallel here. So you're looking for a number under 10.
Yep.
yeah,
What's
it
under
looks
10?
looks like I copied and pasted the answer before the question, or I missed the question. One
No,
of the
but
two.
that's good. I like that.
Roll with it,
So I-
Jim, roll with it.
Okay, so we're playing Jeopardy where you have to ask the question. Is that right?
Get the answer first and then ask the question.
Yeah. What is the total resistance of a 10 ohm, a 20 ohm, and a 50 ohm connected in parallel? And like everybody said, it's got to be lower than the 10 ohm.
Yep.
Yeah.
But close to 10 ohm. So
Yep.
B is definitely not there.
Mm-mm.
So it's got to be the A.
I was talking to Jim this afternoon on the phone, and what we're trying to do is we're trying to de-stress you, give you a second way to look at some of these questions so you can put more energy on the ones you're not sure of. So
Yeah.
that's why I was give you some of these shortcuts.
Yeah,
Yep.
that's good.
Okay.
And
Thank
and
you.
there's where I should have pasted those equations. So let me fix that one. G5C15 move figures. Wow, quality control today is just
Hey, you've got to put together.
okay. 4.4 reactance, impedance, and resonance. 7 questions.
Jim, I'm normally do that about 10, 11 o'clock at night when I'm tired.
That's
I do the same things.
yeah. That was kind of getting late yesterday. What is reactance? A, the opposition to the flow of direct current caused by resistance. B, the opposition to the flow of alternating current caused by capacitance or inductance. C, a property of ideal resistors in AC circuits. Or D, a large spark produced at switch contacts when an inductor is de-energized.
Bravo. Opposition to the flow.
Bravo is correct. Which of the following causes opposition to the flow of alternating current in an inductor? A, conductance. B, reluctance.
I like that one.
C, admittance. Or D, reactance.
Reactance.
Yes.
Delta. Sorry.
Delta is correct. Reactance. I'm not reluctant anymore.
I like to be.
Oops. Hit too many fast. Okay, which of the following causes opposition to the flow of alternating current in a capacitor? A, conductance. B, reluctance. C, reactance, or D, admittance?
Charlie,
Fast you saw the answer was Charlie.
It's still
Reactance.
reactants,
it's
same,
still reactants.
How does an inductor react to AC? A, as the frequency of the applied AC increases, the reactance decreases. B, as the amplitude of the applied AC increases, the reactance increases. C, as the amplitude of the applied AC increases, the reactance decreases. Or D, as the frequency of the applied AC increases, the reactance increases.
Delta.
delta,
Yeah.
Delta
These are
is correct.
These are frequency questions, not amplitude questions. Yeah.
Yeah.
And that kicks out two of the answers. So now you got 50% chance instead of 25. So
Okay.
inductors like low frequency and high current.
Like DC.
Okay. So now the opposite. How does a capacitor react to AC? A, as the frequency of the applied AC increases, the reactance decreases. B, as the frequency of the applied AC increases, the reactance increases. And we're going to skip the amplitudes, C and D, because they're just distractors.
alpha,
Alpha.
AC increases.
Alpha is correct.
Is-
What unit is used to measure reactance? A, farad, B, ohm, C, ampere, or D, Siemens?
Problem.
Bravo,
Reactance
ohms,
is ohms. Impedance and resonance, 7 questions. What is impedance? A, the electric charge stored by a capacitor. B, the inverse of resistance. C, the opposition to the flow of current in an AC circuit. Or D, the force of repulsion between two similar electric fields.
Charlie.
Charlie, the
Charlie.
opposition to the flow of the current.
AC.
Charlie is correct. What happens when the impedance of an electrical load is equal to the output impedance of a voltage source, assuming both impedances are resistive? A, the source delivers the minimum power to the load. B, the electrical load is shorted. C, no current can flow through the circuit. Or D, the source can deliver the maximum power to the load.
Delta,
Delta is correct. You have a matching loads, so you're getting the most out of it. What is one reason to use an impedance matching transformer? A, to minimize transmitter power output. B, to maximize the transfer of power. C, to reduce power supply ripple. Or D, to minimize radiation resistance.
B,
Bravo.
bravo,
B,
Maximize.
bravo.
transfer.
Maximize that power transfer. Which of the following devices can be used for impedance matching at radio frequencies? A, a transformer. B, a pi network. C, the length of transmission line. Or D, all these choices are correct.
Delta.
Delta,
Delta is correct. Each one of those is a valid matching for radio frequencies. Which of the following describes one method of impedance matching between two AC circuits? A, insert an LC network between the two circuits. B, reduce the power output of the first circuit. C, increase the power output of the first circuit, or D, insert a circulator between the two circuits?
Alpha.
Alpha is correct. Insert an LC network. What is the turns ratio of a transformer used to match an audio amplifier having 600 ohm output impedance to a speaker having 4 ohm impedance? A, 12.2 to 1, B, 24.4 to 1, C, 150 to 1, or D, 300 to 1?
Charlie.
Nope. It's gonna be
Oh,
Alpha.
A.
it's alpha, A
Yeah.
12.2.
600 divided by 4, then take the square root of that.
Yeah,
Give you
yeah.
150, the square root of that's just a little over 12.
Yeah.
Yeah. We're not talking doing voltages here. We're doing ohms, resistance. Yeah. So watch that one.
Hmm.
And there's only one question like this.
Yeah, it's kind of tricky.
Okay.
I come out of the audio world and into professional radio. I was dealing with dBms and 4 ohms, 8 ohms, 150, 600 ohms. Those are the things I was dealing with all the time.
Yeah, so that's actually on page 422. Example number 28 gives you the math.
Yeah.
Oops. Yeah, that guy right there. Kind of hard to see. I don't have my other thing going here.
Well, it's 600 divided by 4 ohms and take the square root of that.
Yep.
Yep.
Okay, what happens when an inductor is operated above its self-resonant frequency? A, its reactance increases. B, harmonics are generated. C, it becomes capacitive. Or D, catastrophic failure is likely.
Alpha. Oh, C.
It becomes capacitive.
We think up to this point, we've thought of a resistor as pure resistance, a capacitor is pure capacitive, and inductor is pure inductives. But they have a little, the inductor and the capacitor has a little bit of inductance with it and a little bit of capacitor. The leads of a capacitor form a little bit of an inductor and they become self-resonant at some frequency.
Okay.
What's the question here? The inductor here, yeah.
Wow.
That's on page
Should have read
422.
that section.
So an inductor is not purely inductive.
Okay, yeah, it's at the very top in that first paragraph, G6A11.
Yeah.
And it gives a caution, this can cause slight problems in a radio frequency circuit.
And they bring that up. So when you get into microwave and gigahertz circuits, these things start happening. Yeah.
Yep.
Okay, next section is active components, semiconductor. 4 questions. What is the approximate junction threshold voltage of a germanium diode? A, 0.1 volt, B, 0.3 volts, C, 0.7 volts, or D, 1.0 volts?
Bravo.
Bravo.
Germanium is B, bravo, 0.3 volts. What is the approximate junction threshold voltage of a conventional silicon diode? A, 0.1 volts, B, 0.3 volts, C, 0.7 volts, or D, 1.0 volts?
Charlie,
Really?
7.
Charlie is correct. What is the stable operating points for a bipolar transistor used as a switch in a logic circuit? A, its saturation and cutoff regions. B, its active region between the cutoff and saturation regions, or C, its peak and valley current points, or D, its enhancement and depletion modes.
Alpha, saturation,
Alpha is between the saturation and cutoff regions. That's where it's stable.
okay.
Which of the following describes the construction of a MOSFET? A, the gate is formed by a back bias junction. B, the gate is separated from the channel with a thin insulating layer. C, the source is separated from the drain by a thin insulating layer. Or D, the source is formed by depositing metal on silicon.
Bravo, it's a gate.
Bravo is a gate is separated
mean,
with a small little channel. So
thin.
you have the little channel between the source and the drain, and then the gate gets plopped right in there.
What I think of normally on this one is a C with something in the middle of the C.
Yep.
The story I tell the technicians, you may have heard this one, is a Civil War story where there's 400 Alabamans on a hill over a bridge where 10,000 Union soldiers wanted to cross the bridge, and they'd shoot the guys off the bridge. So they're not on the roadway, but they're separated from the roadway, but they control it with their rifles. And then at noon, another 10,000 Union soldiers showed up. This is actually a true story. And then about 3 o'clock, the Alabamans got hungry, went off for supper. And what happened to the Union soldiers? They ran across the bridge because the gate wasn't controlling it. It was open.
Okay,
So that's what I think about a MOSFET. A C with the guys on the hill in the middle shooting the soldiers off the back bar, the
Okay.
vertical line of the C.
Ooh, vacuum tubes.
Old school.
Going to the old school. Which element of a triode vacuum tube is used to regulate the flow of electrons between the cathode and the plate? A, the control grid. B, the heater. C, the screen grid. Or D, the trigger electrode.
I'm thinking alpha.
alpha, control
Yeah,
grid,
Control and regulate. Yeah.
So, yep.
The screen grid is a help to reduce the excess capacitance found in there.
What is the primary purpose of a screen grid in the vacuum tube?
Just to get into that.
What was the answer?
A.
Alpha is
Alpha.
correct.
alpha.
Grid
Yeah.
to plate capacitance.
The reason we still talk about tubes is when you get your linear amplifiers for HF, they still have, a lot of times will have tubes in the finals.
Okay, now the fun analog and digital
Boolean logic.
in the Boolean logic. So I'll just plop that in there. This is an, where'd the mouse go? This is an AND gate. This is a NAND gate, and you can tell the NAND has a little dot or the little line. I've always seen this. Has anybody seen this in the schematics?
Nope.
I've never seen that.
Never
I've
seen
always
that.
seen this in things.
Yeah.
And then this is an OR. The OR gates are over here, and then the NOR with the little dot on it. And then here's an inverter. Looks like a triangle with a dot on it. And then here's the clock flip-flop. What is meant by the term MMIC? A, multi-megabyte integrated circuit, monolithic microwave integrated circuit, military manufactured integrated circuit, or modulated integrated circuit.
Delta.
Bravo.
Bravo, monolithic, right? Microwave,
It's,
Yeah.
yes, it's a microwave IC chip for high frequencies.
And that's a lot of M&Ms.
Yeah.
Which of the following is an advantage of CMOS integrated circuits compared to TTL integrated circuits? A, low power consumption. B, high power handling capacity. C, better suited for RF application. Or D, better suited for power supply regulation.
Alpha.
Alpha is correct. It's lower power consumption.
okay.
What kind of a device is an integrated circuit operational amplifier? A, digital. B, MMIC. C, programmable logic. Or D, analog.
Analog,
Delta.
del,
Yeah, they're called
set,
OP amps, and they're used for audio quite a bit. This is why our audio boards have got so fancy. So in the last 10 years, they're, yeah,
Yep.
it's an audio analog amp.
Which of the following describes the function of a two-input AND gate? So this is going through our truth tables.
Yep.
The output is high when either or both inputs are low. B, output is high only when both inputs are high. C, output is low when either or both inputs are high. D, output is low only when both inputs are high.
Bravo.
Bravo, it's both,
Bravo is correct.
Oh, muted.
I hear some other.
Yeah, I was wrong question. Wrong
Okay.
question. No.
B is the correct answer on an AND. You get a high output when both inputs are high.
That was the next question. Sorry
Which-
about that.
Which of the following describes the function of a two-input NOR gate? A, the output is high when either or both inputs are low. B, the output is high only when both inputs are high. C, the output is low when either or both inputs are high. Or D, the output is low only when both inputs are high.
It'd be Charlie.
Charlie, it's low in both.
Yep.
That is correct. Charlie is correct. Output is low when either or both inputs are high. How many states does a 3-bit binary counter have? A, 3, B, 6, C, 8, or D, 16?
Charlie.
Charlie.
Charlie is correct.
Charlie, 8.
What is a shift register? A clocked array of circuits that passes data in steps along the array. B, an array of operational amplifiers used for tri-state arithmetic operations. C, a digital mixer. Or D, an analog mixer.
Alpha.
Alpha,
Alpha is correct. A clocked array of circuits that passes data, shifts it down the next guy. Microprocessors and related components. What is meant by the term ROM? A, resistor operated memory. B, read-only memory. C, random operational memory. Or D, resistant to overload memory.
Bravo.
Bravo, read-only memory, right?
Bravo is correct. What is meant when memory is characterized as non-volatile? A, it is resistant to radiation damage. B, it is resistant to high temperatures. C, the stored information is maintained even when power is removed. Or D, the information stored cannot be changed once written.
Charlie.
Charlie is correct. It is maintained even when the power is removed. How is an LED biased when emitting light? A, beyond the cutoff. B, at Zener voltage. C, reverse biased. Or D, forward biased. Delta is correct. When it is forward biased, that's when the LED
Oh,
will
yeah.
emit light. Which of the following is a characteristic of a liquid crystal display? A, it uses ambient or backlighting. B, it offers a wide dynamic range. C, it consumes relatively high power. D, it has relatively short lifetime.
Alpha.
Alpha.
Alpha is correct. It uses the ambient light or it has a backlighting circuit to make it stand out. Practical circuits, we're almost to the end. Rectifiers and power supplies. 8 questions. What useful feature does a power supply bleeder resistor provide? A, it acts as a fuse for excess voltage. B, it ensures that the filter capacitors are discharged when power is removed. C, it removes the shock hazards from induction coils. Or D, it eliminates ground loop current.
Bravo. Bravo.
Bravo is
Yeah.
correct.
Bleeder. Yeah,
When
bleeder.
when you open a case, it'll have a lockout switch sometimes and make sure the power is disconnected from the circuit, but it still has those filter capacitors in the power supply are still fully charged. And it takes, you got time constants in there. And at one time constant, you have discharged 63%, you're down to 36%. And if you got 1,000 volts, that's 360 volts. That's still pretty high. It takes
Mhm.
about 5 time constants to get it down under 30 volts on that. So that bleeder resistor is there to help take that charge off the capacitor because that's like a big battery in the power supply, so you don't get shocked. So you can disconnect the power, open the case, walk away, go get a couple cups of coffee, then come back and work on it.
Yeah. They mentioned in the videos you should allow up to an hour on some because of the capacitors that are in some of.
There's a question in the extra class that's 7.5 minutes times 5, so it gives you 35, almost 40 minutes, 37.5 minutes to let it discharge down.
Wow.
Yeah. Which of the following components are used in a power supply filter network? A, diodes. B, transformers and then transducers. C, quartz crystals. Or D, capacitors and inductors.
Delta.
Delta.
Capacitors.
Delta is correct. Capacitors and inductors. Which type of rectifier circuit uses 2 diodes and a center tapped transformer? A, full wave. B, full wave bridge. C, half wave. Or D, synchronous.
Alpha.
Full wave.
Alpha is correct, the full wave. What is an advantage of a half wave rectifier in a power supply? A, only one diode is required. B, the ripple frequency is twice that of a full wave rectifier. C, more current can be drawn from the half wave rectifier. Or D, the output voltage is 2 times the peak output voltage of the transformer.
Alpha.
Alpha.
Alpha is correct. Only one diode is required in a half wave rectifier power supply.
That's the only advantage.
Yeah, you got lots of ripple though. What portion of the AC cycle is converted to DC by a half wave rectifier? A, 90 degrees, B, 180 degrees, C, 270 degrees, or D, 360 degrees.
Bravo.
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 Bravo is correct. The first
80.
180 degrees.
Jim, go back to the last question, G74. Sometimes if you're looking for a Vox, you can put a half wave diode in there, and you can use that power to operate a switch on that. So you don't need a lot of rectification on it. You just need enough DC to turn on a relay. So you filter off some of the voice coming in, and you run it to a relay that turns the transmitter on. So there is a reason for a half wave on some of these radio circuits. Go ahead.
Okay. What portion of the AC cycle is converted to DC by a full wave rectifier? A, 90 degrees, B, 180 degrees, C, 270 degrees, or D, 360 degrees.
Full wave 360. Delta.
Correct. Full wave
Using
is
the full-
360.
Yeah.
It's using the full wave, the 360. The half wave is only using half of that, the 180.
Yeah.
Okay. What is the output waveform of an unfiltered full wave rectifier connected to a resistive load? A series of DC pulses at twice the frequency of the AC input. B, a series of DC impulses at the same frequency as the AC input. C, a sine wave at half the frequency of the AC input. Or D, a steady DC voltage.
Alpha.
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 Alpha is correct. You'll get a series of DC pulses at twice the frequency. Which of the following is an advantage of a switch mode power supply as compared to a linear power supply? A, faster switching time makes higher output voltage possible. B, fewer circuit components are required. Or C, high frequency operation allows the use of smaller components. Or D, all these choices are correct.
Charlie.
High
Charlie.
frequency. Charlie.
Charlie is correct. You can use smaller components. That's why we get the really small wall warts. All right. I think this is the last part.
Woohoo.
Batteries and chargers. 6 questions. What is the name of the process by which sunlight is changed directly into electricity? A, photovoltaic conversion. B, photon emission. C, photosynthesis. Or D, photon decomposition.
Alpha.
Alpha is correct. Photovoltaic
Photo.
conversion. Yep. What is the approximate open circuit voltage from a fully illuminated silicon photovoltaic cell? A, 0.02 volts DC. B, 0.5 volts DC. C, 0.2 volts DC, or D, 1.38 volts?
Delta.
Baker is the correct answer. 0.5 volts DC for a silicon photovoltaic cell.
What they a lot of times will do, they'll put 18 of them together, and to get the voltage up.
Okay. What is the reason that a series diode is connected between a solar panel and a storage battery that is being charged by the panel? A, the diode serves to regulate the charging voltage to prevent overcharge. B, the diode prevents self-discharge of the battery through the panel during times of low or no illumination. C, the diode limits the current flowing from the panel to a safe volume. Or D, the diode greatly increases the efficiency during times of high illumination.
Bravo.
Bravo.
Yep.
Bravo is correct.
That's so, okay.
You don't want to backfeed
Hmm.
and deplete your battery by pushing it back into the solar panel.
Yeah.
Which of the following is a disadvantage of using wind as the primary source of power for an emergency station? A, the conversion efficiency from mechanical energy to electrical energy is less than 2%. B, the voltage and current ratings of such systems are not compatible with amateur equipment. C, a large energy storage system is needed to supply power when the wind is not blowing. Or D, all of these choices are correct.
Charlie.
Early.
Charlie is correct. A large energy storage system is needed when the wind's not blowing. What is the minimum allowable discharge voltage for a maximum life of a standard 12-volt lead acid battery? A, 6 volts, B, 8.5 volts, C, 10.5 volts, or D, 12 volts?
Uh,
Charlie.
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 Charlie is correct. Don't let it go down below 10.5
Yeah,
volts.
D's you're safer, but.
Yeah, D is a lot safer. And yeah, because that was also brought up by KE0OG. He says, I disagree with this. I don't like to let my batteries go below the 12 volt. What is an advantage of the low internal resistance of nickel cadmium batteries? A, long life. B, high discharge current. C, high voltage. Or D, rapid recharge?
Bravo.
Bravo.
I
Bravo.
discharge.
Bravo is correct. With the low internal resistance, you'll get a higher discharge current.
Yeah.
Oh, I thought I was done. We have connectors, 5 questions. Which of the following connectors would be a good choice for a serial data port? A, PL259, B, a type N, C, a type SMA, or D, a DE9, Delta Echo 9, also known as a Delta Baker 9.
I was gonna say D, but I never heard of a DE9.
Yeah, D, Delta Echo 9, which is also called a DB9. Yeah, I questioned that one and I looked it up in the book and then I Googleized it and I go, oh yeah, I guess I've never heard it called a DE9, but yeah, don't know why.
Yeah, I don't know why that's in there, but it's been there for a long time.
Yeah, I've always called it a DB9. Which of the following describes a type N connector? A moisture-resistant RF connector useful at 10 gigahertz. B, a small bayonet connector used for data circuits. C, a threaded connector used for hydraulic systems. Or D, an audio connector in surround sound installations.
Alpha.
Alpha is
Alpha?
correct. It's a more moisture-resistant RF connector. What is a type SMA connector? A large bayonet connector usable at power levels more than 1 kilowatt. B, a small threaded connector suitable for signals up to several gigahertz. C, a connector designed for serial multiple access signals. Or D, a type of push-on connector intended for high voltage applications.
Bravo.
Bravo is correct. It's the small threaded connector. Which of these connector types is commonly used for audio signals in amateur radio stations? A PL259, B, a BNC, C, an RCA phono, or D, a type N?
Charlie.
Charlie.
Early.
Charlie is correct, an RCA phono plug. Which of these connector types is commonly used for RF connections at frequencies up to 150 megahertz? A, octal, B, an RJ11, C, a PL259, or D, a DB25?
Charlie.
Charlie.
Charlie. Yep, Charlie is correct, the PL259. Wait a sec, I'm getting all confused. Basic test equipment's gotta be the last section. Am I getting tired or what?
It is the last one.
It is the last one. Who double checked? What item of test equipment contains horizontal and vertical channel amplifiers? A, an ohm meter. B, a signal generator. C, an ammeter. Or D, an oscilloscope?
D.
Delta.
Delta, an oscilloscope. Which
Correct.
of the following is an advantage of an oscilloscope versus a digital voltmeter? A, an oscilloscope uses less power. B, complex impedances can be easily measured. C, input impedance is much lower. Or D, complex waveforms can be measured.
Delta.
Delta.
Delta is correct. You can view the complex waveforms and measure them. Which of the following is the best instrument to use when checking the keying form of a CW transmitter? A, an oscilloscope. B, a field strength meter. C, a side tone monitor. Or D, a wave meter?
Alpha.
Alpha is
This is related to the last question. When you're looking at the complex waveform, if you got a spike at the beginning of your square wave on the CW or the spike at the end, you're going to get a chirp sound on it. And you can help eliminate that by adjusting it while you're watching it on the oscilloscope. Right?
What signal source is connected to the vertical input of an oscilloscope when checking the RF envelope pattern of a transmitted signal? A, the local oscillator of the transmitter. B, the external RF oscillator. C, the transmitter balance mixer output, or D, the attenuated RF output of the transmitter?
Delta.
Delta,
Yeah, you can
Delta,
blow that oscillator up really fast if you don't attenuate that signal down, because you're getting 100 watts out, and you want to put several mega ohms, maybe 100 mega ohm resistor in there to get it down to a low value, so you don't blow the front end of the oscillator up, oscilloscope up.
why is high impedance, high input impedance desirable for a voltmeter? A, it improves the frequency response. B, it decreases battery consumption in the meter. C, it improves the resolution of the readings. Or D, it decreases the loading on circuits being measured.
Delta.
delta,
Delta is correct. It decreases the loading of the circuit being measured. What is an advantage of a digital voltmeter as compared to an analog voltmeter? A, better for measuring computer circuits. B, better for RF measurements. C, better precision for most uses. Or D, faster response.
Charlie.
Charlie, better pres-
Charlie is correct. Better precision for most uses. Which of the following instruments may be used to monitor relative RF output when making antenna and transmitter adjustments? A, a field strength meter. B, an antenna noise bridge. C, a multimeter. Or D, a Q meter.
a field strength meter, alpha,
Alpha is correct. I use a field strength meter. Which of the following can be determined with a field strength meter? Very similar to another question. A, the radiation resistance of an antenna. B, the radiation pattern of an antenna. C, the presence and the amount of phase distortion of a transmitter. D, the presence and amount of amplitude distortion of a transmitter.
Bravo.
Bravo, radiation pattern,
Correct. Radiation pattern of the antenna. Which of the following can be determined with a directional wattmeter? A, standing wave ratio. B, antenna front to back ratio. C, RF interference. Or D, radio wave propagation.
alpha, standing wave,
That is correct. You'll get an SWR meter when you have
Yeah.
directional forward and reverse.
Yeah.
Which of the following must be connected to an antenna analyzer when it is used for SWR measurements? A, receiver. B, transmitter. C, antenna and feed line. Or D, all these choices are correct.
no, antenna and feed line, C, Charlie, forget it.
Charlie is correct. What problem can occur when making measurements on an antenna system with an antenna analyzer? A, permanent damage to the analyzer may occur if it is operated at a high SWR. B, strong signals from nearby transmitters can affect the accuracy of measurements. Or C, the analyzer can be damaged if measurements outside the ham bands are attempted. Or D, connecting the analyzer to an antenna can cause it to absorb harmonics.
I'd go for Bravo, strong signals
Yeah, it's trying to.
nearby, yeah,
Bravo is
Bravo.
correct. You don't want to be transmitting close by to it because it'll affect it. What is the use for an antenna analyzer other than measuring the SWR of an antenna system? A, measuring the front to back ratio of an antenna. B, measuring the turns ratio of a power transformer. C, determining the impedance of coaxial cable. Or D, determining the gain of a directional antenna.
Charlie, the impedance of a coaxial cable.
That is correct, the
I mean,
impedance.
yeah.
Yep. What is the insistent, or what is the instance in which the use of an instrument with analog readout may be preferred over an instrument with a digital readout? A, when testing logic circuits. B, when high precision is desired. C, when measuring the frequency of an oscillator. Or D, when adjusting tuned circuits.
Must be delta.
So, yeah.
Delta is correct. You use an analog when you're adjusting tuned circuits.
Ooh,
Dip. That's all,
Oh.
folks.
That's it? All right.
ooh, nice. Nicely done.
Ooh,
Thanks so
that-
much.
On that last question, when you're doing a tuned circuit, you'll see a dip in the current, the plate current, and that is not picked up with the digital meters. But you'll
Yeah.
see the needle make a dynamic dip down when it hits maximum power
Yeah.
transfer at the tuned point. So
Yeah,
you'll see it on the needle, but you won't see it. The digital meter will not recognize it.
Yeah, I still have an old dip
Okay.
meter. I still have an old dip meter with the different attachments that you can plug into the thing.
I've got one too, so.
Okie dokie.
Cool.
Great stuff, Jim. Thanks.
Thanks, Jim.
You made it through. Woo!
That was,
Yeah.
that was a big chapter. My goodness.
That is a huge chapter.
If you guys go to page 443, you're going to see a bird watt meter in here. And they got these little slugs that are about the size of a quarter and about an inch thick. They plug in, they have an arrow going one direction, and you can turn them 180 degrees and the arrow goes the other direction. That's going to give you your directional watt readings. And those things are still being used. Yeah, those are still being used. So,
That's kind of scary.
I mean, yeah, you can talk about that, but I mean, I got guys who just swear by it. That's all they
Yeah.
they'll always use that
Yep.
on the
If
repeaters
it
like that.
works,
Yeah,
keep it going, you know?
Yep.
it's an old standby. You got those slugs are rated for different frequencies and different wattage, like a 5 watts, 25 watts, 100 watts, and so you get a whole bunch of money in those little slugs as they call them.
Yep.
But you'll turn them to the left is reverse, and to the right is forward power, and they read off the meter.
We were taught to be very gentle with those in the 1970s because they're very expensive.
Yeah, well, they're still expensive. They're still around too.
Yep. And my dad was saying, "Oh, we had those in the 50s." I was going, "Holy smokes!" So yeah, they're still very popular.
I've been helping installing a lot of the DMR repeaters in Western Washington, even Eastern Washington. And Rob Chatham, who goes with me, always carries his bird watt with him. He's always using it. So.
Any other questions for tonight through that big long section?
That was very helpful. Thanks.
Lot of long videos on that one.
Mm.
So chapter 5 is radio signals and equipment. 24 pages. Looks like just 2 longer ones and not too bad. So about an hour and a half or so. Or no, about 2 hours. Because 5.4, he's got another video there.
Do you guys like this course? Is it helping you out understanding this stuff? The videos and all?
It is. I've been doing practice tests every day, and I've gone from about 50% right to between 60 and 70 so far.
What was we talked about last night in the board meeting with Scott Robinson is when you're getting to 80 to 90%, it's probably time to take the test. You can go ahead and come finish the rest of the class, but if you're ready to take the test, you might want to go ahead and take it before the rest of the class. We've got 73 people in the 3 classes. And if we can get a few of you guys tested out before the rest of the guys, it'll help out the load at the end.
Okay.
Good point.
But don't worry about it if you're
Yeah.
not ready.
Not-
Like Ernest and Julio Gallo, we will serve no wine before it's time.
Yeah. If you're not ready, don't worry about it. Just go through the whole class because every week you'll get better and better on those scores.
Hmm.
Yeah.
So,
Are you sure about that?
I am
In theory,
sure.
huh? In theory.
after seeing a couple thousand students, I am sure, yes.
I hope so.
Okay, I'll put the disclaimer. Actual results may vary.
Yeah. Oh, come on, Jim. Don't backpedal now.
Promises have been made.
Yeah, no kidding.
No, if you guys make the dedication to go through this course, you will pass.
Hmm.
Yeah.
I'm confident about it.
So
And it's well worth getting that general license.
yeah, because you get into the HF real good. You get that good first chunk to play around. So Jason, I'm gonna put you on the spotlight. Originally, when
Yeah.
I was talking about doing these, I said I don't want to just do review of the questions, but then the more I got into it, the more I realized that the majority is going to be question reviews. How do you find this with having the videos and then the reading and then doing the reviews?
Yeah, you're right. Early on, I was concerned that, well, I just don't want to study answers. I want to be able to get more out of it. And I think that the combination of all of it, and having, being able to watch the video, read through the text, and then have a discussion here if we had questions or needed further clarification, with yourself or Daniel or other folks that are here on the call, is really helpful. And I think, for myself, it's daunting. It's a lot of information. I'm sure this is for a lot of us, but I think with the 3 things, if you can focus on the videos, for me have helped, because it's kind of like being in the class and kind of watching it. And also sometimes I'll back up the video and watch a section again and be able to have that capability with all 3 components, with the class, the video, and the book, for me have been helpful. It's not the same as being in Daniel's class for my tech when I was in Issaquah, but it's next best thing. So I think it's really good. I appreciate the opportunity to hear the questions and hear, again, some discussion when it occurs.
Well, one thing that I'm finding that we're having less questions here because you guys have done your homework and watched the videos.
Yeah.
And I did.
And some of it is purely, I'll be honest, I'm going to have to just memorize some of the answers on the
Oh, yeah.
equations.
Yeah.
It's just, I can memorize the answer. I can see the answer better than I can sometimes remembering the equation. Now I'll probably use it just like that person asked at the beginning of the call. I plan on brain dumping onto my piece of paper, with some of that stuff to help, but
I
Yeah.
get it wrong enough times, I'll get it.
Yeah.
yeah.
Yeah, and then it helps you. A lot of the test question sites, they look at that and they say, "Hey, go back and review this area," so that you can review the areas that you're struggling with.
One of
Yeah,
the things I made for the extra class was a list of the 9 diodes, the 4 type amplifiers, as well as the different capacitors, I think it was. Let me get those things out to Jim. We can get them dispersed out. But there's 4 amplifiers: the op amp, the monolithic, the bipolar transistor and the FET transistor. And I kind of compare the four of them for the answers in the question pool in here. But what helped me was to see a list of some of these things, because you say, oh yeah, that's a Zener diode. And then the next question is, oh, that's a Schottky diode. And then by the end, you get them all mixed up, but you see them in a list and a little different description of each one. It may help you out to keep them separated.
Yeah, good point.
Well, I've been through this a bunch of times.
Yeah. Yeah, and this is my first time.
I wouldn't have
Doing
guessed.
great, man.
Yeah, I think what's been helpful too is taking the book and highlighting, obviously where the question is, and then highlighting where the answer is in the text, preceding the question number. Because then as I'm skimming through it and kind of restudying, it draws my attention to, okay, this is the answer. Great amount of text and detail around it, but then here's also what I'm looking for. So
Yeah.
that's
And
helped me.
on the electronic, the Kindle version, you can click on that question number and it'll pop you to the backside where the actual question is.
Oh, nice.
And then you can, there's a button back there to bring you back to the text portion.
That's
So
cool.
when you're doing your study of just the question pool, you can go back there and, read each of the questions and you go, I got this, ding, ding, ding. And then if you don't figure it out, you can click on it and it jumps you back to the front. So I kind of like both, but I'm still an old school book person, but I went ahead and got both of them so that I could try to copy in the math and things like that. And I did pretty good, except tonight I buggered up 3 of them. Oh well.
That's just copy and paste here.
Gee, out of how many?
Yeah, out of how many? Yeah, that was the biggest thing, getting into the math and things. I wanted to have the examples so that, if you see it with the answer, hopefully it goes, oh yeah, that's right. There's the formula for it. Okie dokie. If there's nothing else, I think I'll stop the recording and